everything you want to try to find illustrations for your slide. So I thought, I want to have something to illustrate this talk, something visual. So I just put the title of my talk. And this is what I got. And you say, what's the connection? Well, this is what I Googled. What is a creative idea? And that's what I got. You see idea there, creative, you know. Good. Okay, what I'm going to do is give some formal definitions. This is a very analytical, not very analytical. I'll get the data later on. Okay? And how they have certain kinds of implications for the cognitive study of creativity. Okay? Let me start off with just sort of a general introduction. There's different perspectives on creativity. We often call these 4 Ps, although there's some variation in what these Ps are to people. But one is creativity is often seen as a process. It's particularly true when cognitive psychologists study it. It's creativity is seen as a person. We talk about a creative person. Personality psychologists will take this approach. We talk about creativity as a product. A lot of my research has to do with aesthetics. So what are the characteristics of film or an artwork or a musical composition that make people see it as being highly creative? And here's a new one that you don't always think of, because we often think of things as psychic, purely psychological process. But we also talk about creativity as persuasion. That is, you have to convince other people that you're creative in order to be really considered creative. I mean, you go ahead and consider yourself creative, and everybody else thinks you're an idiot. But ultimately, there's a social sentiment attached to it for real creativity. Although we're making a distinction between little c creativity and big C creativity in a moment. Okay, underlying all these perspectives is one single unifying concept, and that is the creative idea. Obviously, creative processes are what generate creative ideas. Creative persons engage in creative processes that generate those ideas. Creative products contain those creative ideas that are generated by the creative persons using the creative process. Okay? And then creative products are what persuade others that that person is creative. Okay? So they're all connected. Ultimately, they're all subsumed under the notion of a creative idea. Okay? So by creative idea, I'm just using a very, very broad general sense. Okay? It'll take and encompass a lot of different things. Discoveries and inventions, for example, finding and dividing various things that didn't exist before. Solutions and problems. Problem solving, but also problem finding. Albert Einstein actually said that problem finding is more important than problem solving. He made a name for himself for coming up with problems that no one even thought were problems. He saw an inconsistency between Newtonian mechanics and Maxwell's equations, and everybody else just shrugged their shoulders. So what? Interesting. Okay? And of course, behavioral and ideational combinations like tinkering around, play, fantasy, these are also examples of creative ideas. So I'm going to kind of lump all these things together and just talk about creative ideas. But what makes these various kinds of ideas creative? Right? And this question is not a question of measurement. A lot of people think this is a measurement question. No, it's not a measurement question at all. Okay? It's a question of meaning. It's a question of defining our term. What do we mean when we say an idea is creative? That we can't even talk about measurement until we know what we're talking about. Think about that. Okay? If we don't know what we're talking about, then how can we measure? Let me give you an illustration. Newton's F equals ma. Force equals mass times acceleration. That's one of those famous formulas in the scientific revolution. That is not a measurement issue. That is a definition issue. That's how he's defining force. It doesn't matter whether you're using the English system or the metric system to measure mass. F still equals ma. It doesn't matter whether or not you're measuring the mass on a very, very accurate scale, like the scales that are used in this building. I walked around and saw all the major research being done here. Or your bathroom scale. It's all rusty and raw. It doesn't make any difference. F still equals ma, regardless of how you measure. So that's what I'm talking about. R equals F equals ma in the study of creativity. Okay, let me start off with different types of definition. And generally speaking, there's a lot of definitions, but they can be put into 2 categories. There are the 2 criterion definitions and the 3 criteria definitions. The 2 criteria definition is the one that those of you who have any familiarity with research on creativity are very familiar with. Okay? Usually we say an idea is creative if it's novel and useful. Sometimes they say valuable or some other kind of thing. That's the most common definition. Novel and useful. This is even called the standard definition of creativity. The 2 criteria definition. I think this is totally inadequate. I've published a number of articles showing this is a bad way of defining creativity. Okay? We have to have a 3rd criterion. And now that's very creative. Can you change the lights too? Okay, thank you. All right. Okay. Let me give you some examples of 3 criteria definitions. First of all, Margaret Bowden, who is a philosopher and cognitive scientist, says that something's creative is novel, valuable, no such utility, and surprising. Okay. Teresa Mobley, social psychologist at Harvard, says it has to be novel, appropriate, or useful, or correct, or valuable. She covers her bases. And 3rd, heuristic rather than algorithmic. The task has to be heuristic rather than algorithmic. An algorithmic task is one that you solve step by step using a set of rules, and you're guaranteed a solution. It's like doing long division or extracting square roots by, you probably don't remember how to extract square roots by now, but in those days you did so, okay, that's an algorithmic task, okay? Whereas a heuristic task is one that uses certain kinds of rules of thumb that are not guaranteed to find a solution. Like hill climbing, for example, constantly moving towards a maximum, or means-ends analysis. Those are examples of heuristics, but you don't always know whether or not a heuristic is going to work. And a lot of times you have to devise new heuristics to solve problems. Okay? And that ties in with another distinction, which I really like. David Perkins at Harvard distinguishes between 2 kinds of problems. Reasonable problems that can be solved in a direct, step-by-step manner, and you know exactly what you have to do to get there. It may take you a lot of work to get there. It may be like solving some very, very difficult differential equation, but you know you're going to solve it. Versus unreasonable problems, where you really don't even know where to start. You got to find some insight that will allow you to look at it in a different way, because right now you look at it and you come out blank. Okay? And so that is something that's more related to creativity. And then finally, the U.S. Patent Office has a very interesting criteria. 3 criteria. New, useful, and non-obvious. That's interesting. Non-obvious. And by non-obvious, it don't mean not obvious by the average person on the street. You can say, do you think this newfangled phone is obvious or not? No. It's by people who have ordinary skill in the art, people who have training in that field. What they say, anybody can do this. Okay? And this is a very important distinction. There's a lot of things that are too obvious to get patented. Now, if we can give you one example, how many of you remember when Apple came out with the gold phone? Okay? That is so obvious. I mean, once you have an iPhone 5S, making it come out in gold versions is not any big, surprising thing. It's pretty obvious. Okay? You have to deal with the rich people. Okay. All right, the upper 1%. Okay. Okay. Questions regarding the following definitions. Okay? The foregoing definitions. We have to make a distinction between quantitative and qualitative and quantitative criteria. Are we going to apply these criteria qualitatively or quantitatively? Just say it is new or not. Does it have utility or not? Okay? So is it dichotomous or continuous measure? That's really very, very important. Sometimes have to be one, sometimes the other. Also, how do we put this information together, these criteria together? Is it a kind of a basic additive model? You sum up novelty, utility, and surprisingness, or whatever? Or you have to do a more complex action. So is it a simple combination or integration of information? Or is it a very complex integration of information? Most of it. And we'll see. We literally look at it. Okay? And then finally, this is back to what I said before, we have to distinguish between personal and consensual assessment. Who thinks this idea is creative? Is it just you? Or do other people agree that this is a creative idea? Okay? And so this gets back to what I indicated before. Little c is the personal, and big C is the consensual. Okay? All right. So these three questions will be addressed in what follows, although I have to say, right from the basis, I've never given this talk before, that I may not get to the big C, even though most of my research is in big C, empirical research. Okay. All right. Definitions. I'm going to get a little formal here. Okay? A little bit formal. Let's begin with a set called set X of k ideas. Okay? Obviously, k person 1, 2, whatever. All right? I'll give you a concrete example in a moment. That can be potentially generated by a given individual at a given time period, like in a particular experimental session, giving them a problem to solve. Okay? So we have a list of x1 through xk. Okay? An example is, how many familiar with the Meyer two-string problem? You walk into a room, few of you are, you walk into a room, there's two strings hanging from the ceiling, and you're given instructions. You have to tie them together. That's all you have to do. Okay? The problem is, by the way, can I say something? It really irks me. You can't, this is a lie. Most visual presentation of the Meyer class experiment does not present it correctly. Okay? There's a lot of things wrong with it, but one thing that's wrong with it is in the original Meyer experiment, the strings go all by certain solutions. Okay, certain solutions don't work. Like one, which means, I'm sorry, it can be 0, which means it's useless, or it can be 1, which means it's perfect. Okay? This utility may be either dichotomous or quantitative. It can be a 0, 1 variable, or it can be a number or a proportion that ranges from 0 to 1. Okay? So the former is illustrated by Meyer's two-string problem. You either tie the two strings together or you don't. There's no in-between solutions. Right? It's either a 1 or a 0. Okay? Also, the DNA code, if you look at what Watson had to deal with, Watson Crick had to deal with, there were 4 possible solutions. 3 of them could not possibly work. And one of them had a high probability of working. They weren't guaranteed. They just didn't know which of the 4. So it was actually a 0-1 utility for the 4 possible arrangement of the nucleic acids. Okay? On the other hand, the quantitative example is Edison's search for incandescent bulb. You know, the way we usually present it, it's not right. You know, it sort of looks like, here's Edison, he's in the laboratory, and he just turns on the light, and the bulb either goes on or it doesn't go on. He keeps on doing that until one finally goes on, and then the light bulb goes on. He has an aha experience, and he becomes super rich, and that becomes a metaphor for the act of creation. It wasn't like that. Okay, there's a lot of quantitative parameters he had to deal with. How much resistance there was. The more resistance there was in the filament, the more bright it would be for a given amount of electricity. How long the filament would last before it burned out. Whether or not you could carry it from one room to the other without breaking. I mean, there's a whole bunch of things that he had to deal with. A lot of different parameters. So it was a quantitative measure of utility. Okay? And then the third criterion is the prior, most obviousness, comes from the patent office, the prior obviousness of a particular idea or solution. That is, do you know in advance whether or not this will work or not? Okay? And so this also ranges from 0 to 1. This is the prior knowledge of the utility value. In Meyer solutions, most of the people, for the 3 of the solutions, they knew right away it would work. They saw the chair, oh, can I use the chair? They said, yeah, okay, let's tie the chair, and I'll pull it over, and then I'll tie this into the chair. They knew it at once that it was going to work. Okay? Another one of the items was an extension cord. They knew. They said, can I use the extension cords? What do you use extension cords for? For extending things, right? Well, there's electricity, but anyway, it was obvious. Just absolutely obvious. Okay? But using a pair of pliers, as a pendulum is not obvious. In fact, it's interesting, one variation of the experiment, he actually gave people prior experience with pendulums to see if that increased the probability they'd come up with a pendulum solution. And it didn't increase the probability at all. I mean, it's really astonishing. Okay. Now, you have middling levels, too, and these represent degrees of punchiness or feeling of knowledge states. That's might work, but I'm not quite sure. Okay? So that's why it's a quantitative arrow from 0 to 1. Okay? Ideas that obviously have zero utility are presumably predictable. Or rational being. If you know it's not going to work, you're not going to try it. Okay? All right. Therefore, personal creativity associated with a given idea, xi, is defined by this formula. Very simple. Okay? C times 1 minus p times u times 1 minus p. Now, I know it doesn't look that simple, but it actually is. When you analyze what each of those 3 factors mean. Of course, one we already know it is. Okay? Oh, this rank is from 0 to 1, which is basically the probability that the idea is seen as creative. 0 means, it's not creative at all. 1 means, yes, it's creative. Maximal. Okay? U is obviously the same as before. It's your personal utility. Okay? The final utility. 1 minus p is the personal originality. Okay? I mean, think about it. Originality is when you have a low probability idea. That's how I'm defining it. Okay? And then 1 minus the obviousness is the personal surprisiness. That's the other side of what's obvious is something that's surprising. Okay? So 0 means no surprise, and 1 means eureka. Okay? This is really, really straightforward. Okay? So we're just multiplying originality times utility times surprisiness. Basically, an instantiation, a mathematical instantiation of the US Patent Office definition. Okay? So this is literally little c. That's why I made it lowercase. Literally little c. Later on, we have time on the big C. And it will be uppercase. Okay? It's a personal, quantitative, and multiplicative definition. And that all those components have to be true. Okay? Notice something here. I got rid of novelty. And I don't like novelty. Even the Patent Office has novelty. I don't like that as part of the definition. Now, I actually think that's a conflation of the 2 criteria. It's a conflation of originality, which is low probability, which is surprise, which is how much you know in advance whether or not it will work. Those are not the same things. They can often overlap, but they're not identical. Okay. I'm going to deal with the implications of this. There's 3 implications. One has to do with how do you maximize personal creativity, given this definition. And there's some surprising results of how you maximize creativity in this very simple multiplicative definition. And then, what's the distribution of ideation creativity? If you look at all the ideas that someone generates and then plot the distribution, what does it look like? Is it a normal distribution? You think? So most creative ideas are in the middle range of creativity, about 0.5, or something else. And then finally, the origins of ideational creativity. Where do we get these creative ideas in the first place? And just to anticipate it a little bit, think about it. Creativity maximizes, right, when we don't know what we're doing. So then how can we find out whatever a creative idea is if we don't know in advance where it is? In fact, what I'll show in a moment is that if you know in advance where it is, then it's not creative. Catch 22. Okay? So let's start with maximization. How do we maximize creativity? All right? Creativity maximizes, where C goes to 1, as, first of all, originality maximizes. Or another way of saying that, lower probability. If probability goes to 0 for a given idea, then creativity goes to 1. Quantitative factors. Okay? By the same token, as obvious as the originality goes to 0, or as the probability goes to 1, then creativity goes to 0. Okay? This is true regardless of the other criteria. This is what's very important about getting multiplicative. When you put a 0 there, it makes the product 0. Period. It doesn't matter that the other two criteria are the parameters are 1. Right? It doesn't matter. Okay. So 0 originality automatically means 0 creativity. Okay. And let me give you an example. What if I decided to invent the wheel? Okay. That's 0 creativity. Okay. Even though it's not useful. And I may have some real good reason for thinking that, or I wouldn't be surprised. It would be pretty dumb to be surprised. Okay. Hence, ideas that require an incubation period, let's get back to the one I raised earlier, are more creative than ideas that quickly come to mind as solution in the original set of facts at the moment we really start solving a problem. Okay? And this really gets rid of an argument. There's often an argument. Do you have to have an incubation period to come up with a creative idea? The answer is no, you don't. It can be part of the original set of ideas, it has to be relatively well calculated and highly useful and relatively surprising. Okay? But you don't have to have incubation. But if you do have incubation, if you have to have incubation before you iterate, then that means the initial probability was 0, which maximizes originality. This is cool. It's part of the definition. It's not even a fair question anymore, right? Okay? However, this is very important. The duration of the incubation period is ignored as part of the definition. This is very important. Because I believe that the length of the incubation period is a product of chance, something called opportunistic assimilation. Okay? That you're doing various things, you're working on a problem, you're in an incubation period, and then all of a sudden, something gives you the solution. You're Gutenberg, and you're walking around, and then it happens to be all these wine presses are pressing wine. Have you ever wondered why the original Gutenberg printing press looks like a wine press? Because it was designed to imitate a wine press. Okay? But he didn't know that until he got drunk. Okay? So let me give you an example. Let's talk about the cursory experience of Archimedes. You may know he's trying to solve a problem that the king gave, the king of Syracuse. Right? Tried all his math, tremendous mathematical ability, great mathematician of antiquity. Couldn't solve the problem. And then he decided to take a bath. And all of a sudden he got the solution. But think about it. We shouldn't define the creativity of solution according to how smelly you happen to feel in a particular day. You know, you say, oh, I'll take a bath today, I'll take a bath tomorrow. And that also makes the idea more creative. Okay, I mean, here he is. Eureka. Right? You know, I'm sorry, it doesn't matter when he took his bath. As far as how creative that idea was. You know, it's obvious from space, but it's not period. Okay. Okay. Maximization. Creativity maximizes, again, as utility maximizes. That's obvious. Right? If utility is a quantitative measure, then we're talking about a matter of degree. Okay? Like an example is this alternative incandescent bulb filter that Edison looked at. He looked at over 1,000 different filaments, including really bizarre ones like burning bamboo strands or burning threads of sewing thread. Okay? By the way, it was a sewing thread one that he ended up using. Figure it out. Tungsten didn't work. He tried that. Because he couldn't get enough good enough magic. Okay? He looked at production cost, resistance, robustness, duration, brightness, a whole bunch of other factors. He had a huge notebook with all these parameters, trying to maximize them all. Again, most of them are quantitative variables. Okay? This is an interesting thing. If you have a quantitative utility and you're thinking about maximizing creativity, you can always say, and actually he did this, he probably said, it may be unrealistic to expect to have a light bulb last a long time, like $100 or something. So we settled on 15 hours. Imagine having a light bulb only works for 15 hours. But for the time, that was efficient. Okay? So that means you can gauge who satisfies it. You don't meet all the quantitative criteria 100%. You skip on some of them. Okay? And hope to solve that problem, those problems later. It's good enough. Okay? If U is dichotomous, if it's 0, 1, then creativity only maximizes if utility is 1. Obviously, you can't maximize utility if 0. The multiplicative relationship. Okay. If U equals 0, then creativity is 0. Okay? Regardless of originality and surprise. This is very, very important. Okay? I think a lot of people think if you come up with something really original and novel and surprising or whatever, then it's creative. It's not, doesn't have any usefulness whatsoever. Okay? Like a bank statement made out of syllables. How many of you have ever heard of that before? Okay? This is what it looks like. All right? The utility of this is 0. But I assume the originality is very, very high, and you were probably surprised. Okay? But it's not creative. I mean, it's a creative example of non-creativity. It's not creative. Okay? Okay, creativity maximizes parameter left, right? And surprisingness maximizes. Okay? Or equivalently, as the prior knowledge of the utility minimum equals to total 0. Okay? That is the extent to which we know in advance whether or not that idea will work. Okay? Therefore, to the extent that an idea is expertise-driven, this gets back to the definition of the U.S. Patent Office. Ordinary knowledge of the art. Okay? Then creativity must decline. Okay? And this is like the distinction between algorithmic and heuristic tasks, where you know algorithmic tasks are expertise-driven. You know an algorithm that will solve the problem. And the same thing, the distinction between reasonable and unreasonable problems. And unreasonable problems, you don't know whether it's going to work or not without testing it. If you know exactly how to solve an idea with maximum utility, then the resulting idea can't be created even if its probability is low. This is kind of an interesting concept, and I'm still trying to work out because it's hard to wrap your head around this. So you might not actually know the specific answer, but you know that whatever answer you hit is going to be correct. It could be surprising in a different sense, but it's not surprising that it's the answer. An example is solving a quadratic equation using a quadratic formula. How many remember this from high school? Right? You know, you plug in the coefficients of the quadratic, and it's guaranteed to give you an answer. Now, you may be surprised at some of the answers. You may be surprised to find out that 2 of the roots are identical. Or you may find out that one of the roots is a negative number. Oh, no, it's a square root of a negative number. Okay? That's kind of surprising. That's how they describe the imaginary numbers. Okay, imaginary numbers are not imaginary. They're solutions among other things. Okay? So even though you're not to be surprised at the answer, you're not surprised that you have an answer. It's an important distinction. Okay, special note. When the personal creativity is not maximized at C1, and this is often, you don't always get maximum creativity. A lot of creativity is in the middle ranges. Okay? Then its 3 components can assume a wider range of values. You can have trade-offs between them. You can have a trade-off between originality and utility, a trade-off between utility and surprise, okay, and still get the same product, the same threefold product. Okay? This variability allows for trade-offs, such as sacrificing utility for sake of originality and surprisingness. And this happens all the time. Okay, examples. In the laboratory, the Pliers pendulum solution to the Myers two-strings problem is actually the least useful of 2. It takes more work. You actually have to shorten the string first and set it in motion. Using the chair extension cord or the pole is much faster. But it's more creative. There's most of it. Okay, and you're using a pair of pliers in a different way than you've ever used a pair of pliers before. Okay. Or in the real world. Now here I really like art and my personal aesthetic prejudices imposed on you. Okay, that's my right keynote speaker. Okay. Creativity in Eastern versus Western civilizations. Okay, the trade-offs are often different. Okay, so a good illustration is avant-garde and shop art in the West. if you know what those are, right? So, I'll start off with East. Here's a Persian miniature. I have a thing for Persian miniatures. Okay? And they really are miniature, they're not that big. Okay? And then this is the Southern Sun landscape. Monochrome landscape. The light goes. This is actually a section of it. Okay? So that is something that I would say is very high utility, has aesthetic value. A lot of people can appreciate this environment. Okay? And then in the West, you have, first of all, this. See what this is? The Bacandana caused a big uproar when it was in the Brooklyn Museum. The Mayor of New York line had taken down. And you say, what's wrong with that? Well, first of all, there's elephant on it. Okay? And if you look closely at these things, some of these are phallic, really pornographically phallic images. Or this, how many have seen this? This is a crucifix. What is it in? Do you know? Piss. Okay. What about this? Okay, something either way. Okay, so credits. Okay, the artist with the Persian and the artist with the, you know, and then we have just credits. Okay. See, obviously traders are different. West puts a big premium on shock value, which is surprise. But it's just right now. Okay. I think about, I would say 3/4 of the apps we get put out for our various electronics, for smartphones and work, are useless. They're cool, isn't that cool? Never seen that before. Okay. Now let's look at the distribution. Okay? We have this C as a multiplicative product. Okay? This is very important. Multiplicative functions are different than additive functions. Okay? Alright? Multiplicative function, originality, utility, and surprise. Okay? It necessarily follows that highly creative ideas should be very rare, and non-creative ideas should be commonplace. Which I think is intuitive. Okay? Any definition that doesn't give you that is wrong. Okay? That is, while an idea has to rate high in all three criteria to be creative, it only has to be low on one to be non-creative. So it's obviously higher probability if it's a non-creative idea. Okay? This outcome contrasts with what we obtained were the three criteria integrated in an additive rather than multiplicative. Okay? And I'll give you an illustration of a Monte Carlo simulation I published last year. 2 years ago, actually. God, time flies. I randomly generated 10,000 ideas. Actually, when you think about it, this would take just a few days to generate, because you're generating ideas all the time. Most of which are very mundane. That's weird. No offense. You know, on the sudden, what to eat at lunch? You know, that's not a profound idea. Okay? This salad or that salad. Okay, so this is what you get. Look at that. The probability of producing an idea with maximal creativity is almost zero. Well, it is zero in that here. And most zero creativity ideas, that's where the multiple is. And by the way, there's some tests that show this. There's an interesting test called the Creative Achievement Questionnaire. If you look at the distribution of it, you get the same thing. Because it rates ideas according to how creative they are, including up to award-winning ideas. Okay? Now, if you had an additive model, that's where it goes. Most ideas would be run for mental creativity. Okay? So this is obviously wrong. I mean, it's very nice. It's like, you know, that, like people will be on, all the kids are above average kind of thing. You know, but however flattering it is, it's wrong. This is right. Okay? And this is not dependent on the distribution. This is very important. I happen to use a uniform distribution for the three parameters. Okay, in the Monte Carlo simulation, it doesn't make any difference. It could be normal curve, it could be skewed curves, Poisson distribution. It doesn't make any difference. It doesn't, because of the central limit theorem. You add a bunch of things together, you end up tending to get a normal distribution. That has nothing to do with it. Okay, origins, that's the last one. Where do these come from? how rare highly creative ideas must be, where do they come from? How can they be generated in the first place? Answer, Donald Campbell, back in 1960, was actually the mentor of my mentor in graduate school. So he's my doctoral graduate. He's my doctoral grandfather. I only met him twice, but he's still my grandfather. Came up with the idea of blind creation and selective retention. That's what you need to do. You have to generate ideas blindly, okay, and then you select the ones that work. Okay. This Tony was once asking one of his grad students, how do you come up with all your ideas? And he said, I just generate lots of ideas and then just keep the good ones. Same thing. Okay? Problem, Campbell didn't define his term. He didn't define creativity, he didn't define blindness. Caused all sorts of confusion. This was back in 1960, right? I'm not even in college yet. Okay? This failure led to abundant criticism. How can creativity be blind? That sounds stupid. It's like you just go around being creative. No, it's not like that. Okay? They thought that it required an analogy with Darwin's evolutionary theory, which is totally wrong. He didn't even mention Darwin's evolutionary theory. It's not an evolutionary theory. Although there's certain isomorphisms with evolutionary theory, no doubt. And a lot of people thought, even though he was very explicit, that the blind creation selective retention theory required an idea to be blind and generated randomly. Totally untrue. Okay? So let's say what it actually is, all right? And what I'm going to do is work backwards. It's like the term blindness causes all sorts of hang-ups on people. You know, just the brain gets kind of tripped on it. I'm talking about citedness instead. Okay? So I'll talk about citedness, and then I'll get to blindness through the back door. Because blindness has to come in through the back door, and citedness comes in through the front door. Okay. I'm going to prove that citedness is negatively creativity. Okay. Citedness. For any given idea, we want to say how cited it is. The citedness is just equal to the times utility times the obviousness. Okay? Cited ideas are highly probable, highly useful, and highly probable because they're already known to be useful. That's obvious. Okay? Such ideas represent routine or what is often something called reproductive thinking. Just reproducing what we've already done. Using a solution to work at one time to solve a similar solution now. Okay? Almost all the solutions in the constraining experiment were of this type, I already said. People said it was obvious. I use a chair, I use an extension cord, I use a hole. That's obvious. Okay? Very important. Remember I said that a lot of people use the two-criterion definition? And I say that won't work. I'm going to give you an example why it doesn't work. You have to have that be in there. You have to have your prior knowledge value in there. You have to. And let me give you an example. I'm going to ask you to solve this problem. I'm going to put this coin. And you have to predict whether it comes up heads or tails. Okay? That's all you do. It's solve the problem. And you get paid for how much you get better than 50-50. All right? You don't know it, but the coin is biased. Okay? It's biased for heads to come up more often than tails. Wonders. Guess what? You have a response bias. You're more likely to call heads than tails. And so you do much better than 50%. Do you know what you're doing? Did you solve the problem? Even though you're doing better than chance? No. You were just lucky. It was a lucky guess because your response set happened to go along with the bias in the coin. That's a very simple example. Think of a more complex example. But sometimes you can be right without knowing what you're doing. And you should get credit for that. And that's why you need to have B in there. Prior knowledge. For the entire set of solutions, we can talk about the average citedness of all the various ideas in that set. Okay? And these all range between 0 and 1. Everything ranges between 0 and 1. It's very beautiful. They're all proportions of probabilities. Okay? Citedness is the inverse of blindness. That's what I said. By the way, some people say to me, listen, you can't do this. You can't say that because citedness is a continuous variable and blindness is the dichotomous variable. I don't know how they say this. We have a legal definition of blindness as dichotomous, but if you know blind people, it's not dichotomous. There are blind people who actually can see well enough. I have one student who could actually do path diagrams in this graduate class. They had to be huge, but he could do them. Okay? So it's actually a continuous variable. It's more complicated. Okay? So we can talk about a continuum from blindness to sightedness. All right? This is 1 minus s is blindness. And the same thing calculated for the set as a whole. Blind ideas have low initial probabilities, low final utilities, and low prior knowledge values, or any combination of low values. It only takes one zero value to make it blind. So low probability, non-obviousness, or zero utility. And you don't do it. Hence, although an idea has only one way of being cited, it has multiple ways of being blind. This is interesting. Okay? There's something weird going on here. And this weirdness is actually what provides the room for blind variation selective detection theory. A habitual response that fails because a person is ignorant of that behavior that worked in the past does not apply to the new solution. Okay? So what this says is that this has a high probability that it worked in the past, so it should work now, but you actually don't know that it won't work. You don't realize this problem is actually very different. You overgeneralize. Okay? Hence the bipolar continuum, as I said before. All right? 1, 1. All right. Now I'm just going to stop from writing to the punchline. Okay? Who wrote about blindness? To get back to that, all the false debates initiated by Campbell's theory. Blindness does not require randomness. Okay? It does not require it at all. All randomness is blind. There's no doubt. So if you generate ideas randomly, you're blind by definition. Okay? But not all blindness is random. Random ideas are just a subset of blind ideas. Blind ideas is more conclusive category. That's what we still need. Okay? So a systematic process or procedures can yield ideas that are substantially blind, even though they're systematic. Donald Campbell himself talked about a radar sweep. We have a radar doing a search. That's systematic. It's not random, but it's blind because you don't know where you're going to find that UFO that you're looking for. So you just do a complete search, or search grids in a lot of search disciplines like archaeology and paleontology, and search grids they use to try to find Malaysia 370. They're just blind, okay? Even though they're high systematic, right? There's this program called Bacon that solves scientific problems. Actually, it's plug in the data that scientists use. They plug in the data that Kepler used for his coming up with his third law of planetary motion, and the computer spits out the same solution. Okay? And they go, this is really cool. Computer can be creative. If you look at it very carefully, even though it's highly systematic search, in fact, it's a heuristic search, it generates ideas blindly, tests them, finds out whether or not they work, and then generates a new version of those ideas, different permutation of those ideas. With certain heuristics to kind of reduce the number of steps. Okay? Hence, BDSR does not necessarily operate in a manner analogous to genetic mutation and recombination as in evolutionary theory. That is obviously a difference. Okay, that's no problem. We don't have to operate that way to be formed in our creation. Okay? Blindness does not require equal probability either. Campbell talked about that. You don't have to be equal probability. The key is the probabilities have to be decoupled from the utilities because you don't know what the utilities are. So what you think of a highly probable solution turns out not to be a solution. Something else you think is not likely to be a solution ends up being a solution. So there's a lack of correspondence between the probability and the utility. Okay? Even though equiprobable ideas are more blind than non-equiprobable on the average. Okay. Now when sightedness maximizes, then creativity must minimize. That is, S goes to 1, then that means they all have to go to 1, 3 parameters making a product, and hence creativity has to go to 0. It has to be that way. That's mathematics. Okay? You can't do it right now. All right? It's actually just tolerance. You want to improve. All right? Regardless of the idea's utility, highly cited ideas cannot be highly creative. It's simply impossible. Okay? If you know what you're doing 100%, so there's no guesswork at all, you're not going to produce any creative ideas. I remember this once, this is not my story, this is one of those anecdotes that probably pass around a lot between various people at cocktail parties, whatever. The way the story goes is this one, I think it's a psychology story, boasted that he never ever got a paper rejected that he submitted for publication. Ever. And his friend, or maybe him, I don't know, said, that's really too bad. That's really too bad. Because think about it, he never took any risks, never took any chances. He always knew exactly the journal was himself. There's something wrong with that. Okay? In contrast, when blindness maximizes, now we're on the other end of the distribution, okay, the expected value, or the mean, of creativity with ideas increases. The variance, or sigma, increases. The maximum possible creativity, or Cmax, increases. Whoa! Weird. And the skewness of the joint creativity-sided distribution increases. Now, I know there's a lot to swallow, so this is one of those things where visualizations are better than formalizations, right? So, this is what happens when you do a Monte simulation of this. Okay? You get this distribution. Whoa, this is cool. This is really cool. As sidedness goes to max, notice this doesn't even go to 1. We already created it down to 0 already before you get the sidedness equal to 1. Sided creativity disappears. Okay, when you go here, notice the range increases, the maximum increases, the scatter increases. Okay. Therefore, BDS are absolutely required to isolate the few highly creative ideas from the numerous useless ideas. Okay? To separate the wheat from the chaff. You've all heard that expression. And especially that the grains that are biggest are where the chaff is most venomous. If you saw that, big one. I got, this card in 10 minutes. So if I speed up, you'll know why. Okay. In other words, the function of BSR is to establish knowledge values. That's the useful iteration for convention. To get the knowledge values you didn't have. To find out whether it works or not. Obviously. Sometimes I think this is so obvious that why don't people understand this? Why was it criticized for 50 years? Okay. Well, it's Don's fault. He didn't define his terms. Okay? All right. Presumably on this basis, whenever the knowledge value equals 1, the utility equals 0, then the probability is set to 0 as well. Okay, once you find out it's not going to work, then you change the probability. Part of your expertise is knowing what doesn't work. We often talk about Edison's successes, but he had tremendous failures. He wanted to actually come up with a new electric car, a functional electric car. Everybody knows the main problem with electric cars is what? The batteries. So he wanted to come up with a new battery that would make an electric car practical. This is in the early 20th century. Okay? He tested all sorts of different electrodes and electrolytes, one after another. It was very expensive. Of course, he had a whole big team, working for him at Menlo Park. And finally realizes nothing works. Nothing, no improvement on what they already know. And his coworker said, Tommy, what a waste of time. We tested over 8,000 batteries and none of them work. And he says, yes, but now we know 8,000 things that don't work. Okay, big question. What enables a person to engage in BDSM? This is actually a important question for you to think. There's cognitive processes, your personality characteristics, your experiential factors. I don't have enough time to go over this, but presumably we did the 5-minute call. It's okay. So I can talk about, for example, remote association, which I'm not. I can talk about divergent thinking, which I'm not. By the way, it's 4 different ways in elaboration when it's not relevant. And by the way, don't measure remote association using RAP. Cognitive disinhibition, using reduced inhibition. We talk about personality characteristics, openness to experience. Persistence, motivation, grit, extremely important. Okay, I have some nice quotes about that. If you have lots of failures, then you just gotta hang in there. Remember that thing about Edison, you know? Success is 10% inspiration and 90% perspiration. Okay? Experiential factors. There's long-term effects, like there's correlation studies showing multicultural experiences increase your ability to engage in PSR. Donald Campbell was talking about that in 1960. Short-term effects, laboratory experiments. I even done one laboratory experiment on that. Exposing people to unconventional, incongruous, or unexpected stimuli increases their ability to engage in PSR. Okay. So at this point in my talk, you may be asking, are we there yet? If you're thinking, if you're taking notes, okay, thinking about your notes, unfortunately, not really. We left something out, didn't we? We left something out. What happened to the fourth P? Creativity as persuasion. Okay? What about the distinction between personal and conceptual assessments? Little c and big C. Okay? Well, I'm just going to have to go through this really fast. It turns out we're going to have to introduce judgments of other people, besides your own. We've got 3 parameters. For example, we can define a big C creativity as the average of all the little c creativity assessments, including your own. Okay? The average across the next one, we can do that. That's why it's big C instead of little c, uppercase C. Okay? Which also ranges between 0 and 1. It's an average of 0 and 1 variables. Forget that. So C is the, I'll skip that too. Okay? Yeah, complicating this assessment is, 5 minutes, there's variation. And maybe everybody agrees that this is creative. They all pat you on the back. 1,000 people pat you on the back. But a lot of times they don't. Okay? And so there's variance. So we have to compute the variance in the various separate judgments of people evaluating this act of creativity, this creative idea. Okay? And that variance varies according to fields. There's high consensus field where the variance is very small, and there's low consensus fields where the variance is very high. Okay? And I'll give you an example. In the sciences, for example, here are the high consensus fields. This is based on data, by the way. Actually, I did a data analysis. Here are low consensus fields. Those where psychology is. Kind of cool. Get a little bit more biology in, and we'll be there. A little bit more neuroscience, a little bit of evolutionary psychology, a little more behavior genetics, and we'll be just like biology. Okay. All right. I'll skip that. I'll skip that. I'll skip that. Well, I guess it's just best to say, that's all, folks. There's some time for 1 or 2 questions. There's 2 hands over there. I don't know one. You're supposed to be part of it.
I was just going to ask, in terms of using this, say, if you were managing Pixar this morning, would there be ways that it might be put in place to compare ideas based on creative process?
I've been to Pixar. Pixar's really cool because the way they function is to maximize the generation of blind variation. They would love that, but for example, they allow people to come up with ideas even though they have no expertise in the area. Somebody could be like the editor, and he says, I have an idea for maybe a short. They usually start with a short before they move to the features, right? And they said, go ahead and go with it, even though he has no background. So that's an example where expertise can get in the way. And sometimes, there's this, one of my favorite stories is about Pasteur, who was a famous chemist. He's not known as a famous chemist now, but he started off as a chemist. And he was asked by his teacher, there's a major silkworm disease that's destroying the silkworm industry in France. You gotta do something about this. And he says, I don't know anything about silkworms. And his teacher said, so much the better. There's another question.
I wasn't.
Well, that's the problem. You're the guy in the back. I can't, go ahead, go in the back.
You mentioned Edison a couple times. I was just wondering, you probably studied all sorts of different creative people. In your opinion, who would you say was like one of the most creative people ever and why?
Not counting me. Oh, that guy, it's really hard to do because you have to break it down for any field. I mean, like Edison, obviously the most creative inventor who ever lived. He still holds the record at the U.S. Patent Office for the most patent. But then you start talking about music. I have my own preferences. I'm a Beethoven fanatic, you know. But somebody else may say, Picasso's not even in there. Roll over Beethoven. Way in the back.
Could you tell us a little bit more about the data on the graph you showed us at the end about the hierarchy? Where did that data come from?
Oh, that's an interesting thing. What I did is I took the characteristics of those fields, physics, chemistry, biology, psychology, and sociology, and looked at a lot of different things, like, for example, consensus on who's doing the best work in the field at a given time. How soon a young person just entering the field is recognized as a rising star. Okay? No, there's a bunch of criteria like that. And they're objective. We're not talking about subjective. Well, they're subjective since they're peer evaluations, right? Some of them are peer evaluations. But not all of them are. For example, one of the ways to measure consensus is citation concentration. Do the citations concentrate on certain papers that are considered the classics in the field? And areas in physics, wow, when something comes out, all these citations start gravitating to us. When something comes out in psychology, who was it that said that writing a book of poetry is like a butterfly in the Grand Canyon? You know, I mean, it's just like, it takes a long time to accumulate citations, and the citations, we use something called the Gini index, show they're much more equitably distributed. Yeah, now I'll get you.
I wasn't really clear on what qualifies as utility.
Pardon?
I wasn't really clear on what qualifies as utility.
Well, what qualifies utility largely depends on the domain, right? What are the domain criteria? I mean, obviously, 1 minute. This will be the last question, I guess. Although we'll be signing Genius 101. So if you have another question, buy the book. I'll sign it and answer the question. But not your question. It depends on the field, really. So, I mean, obviously, in the case of like Edison and the light bulb, he had certain criteria that were pretty much his profit criteria, right? In order for it to work, in order for it to be viable. For other things like in art, you know, it's a little bit more iffy. You know, I've done a couple studies on Picasso's Guernica. He was looking at the sketches, and you know, he went through a lot of trial and error to get to that. He threw out a lot of sketches and a lot of ideas. In fact, the current Guernica is radically different from the one he started out with, which is called Artistura. He obviously had in his head something that he wanted was a commission for a special fair. He had something in his head of what would be something that would really show off his stuff. And it took him a while to find it. So you'd have to ask him what his criteria is. But he obviously had something in mind, because he was generating a rejection. Well, that's the last step. Okay? Thank you very much.